As the world outside settles into the deep quiet of night, a profound stillness seems to descend. Perhaps the only sounds are the gentle sigh of the wind through leaves, the distant murmur of a city easing into slumber, or the rhythmic chirp of a lone cricket marking the slow passage of time. Curtains are drawn, lights are dimmed, and breaths deepen into the steady cadence of sleep. We curl up, letting go of the day, trusting the solid ground beneath our homes, beneath our beds. It feels utterly dependable, this earth, a steadfast foundation in the darkness. We drift off, our minds wandering through dreams, blissfully unaware of the immense, silent journey unfolding right under our feet, a journey that has been happening for longer than we can possibly imagine. While we rest, while the moon casts its silvery glow on sleeping landscapes, the planet itself is far from still. It breathes in its own slow geological rhythm. Imagine, if you will, that the very surface of our Earth, the crust we live upon, isn't one single, continuous shell. Instead, picture it as an enormous, intricate puzzle, cracked and divided into immense, irregularly shaped pieces. These aren't small tabletop puzzle pieces, but colossal slabs of rock, thousands of kilometers across and tens, even hundreds, of kilometers thick. Some carry entire continents, their mountains and plains and forests riding passively on their backs. Others form the vast hidden floors of our deepest oceans, landscapes of submerged ranges and abyssal plains unseen by the sun. These giant puzzle pieces fit together, edge to jagged edge, covering the entire globe like the patterned shell of a colossal ancient tortoise. They are known, in the quiet language of geology, as tectonic plates. There are great, continent-spanning plates, like the one carrying North America, or the vast Pacific plate underlying most of that ocean. There are smaller, but still enormous, pieces tucked between the giants, like the Arabian plate or the Caribbean plate. They nestle against each other, their boundaries marked by dramatic features, sometimes towering mountain ranges pushed up by their slow-motion collisions, sometimes deep ocean trenches where one piece slides beneath another, sometimes long, fractured lines across the land. And here is the most wondrous part, the secret the Earth keeps while we sleep. These immense puzzle pieces are not fixed in place. They are adrift. They are moving, constantly, relentlessly, across the deeper, softer layers of the Earth beneath them. Think of them as unimaginably large rafts, floating and gliding on a hidden viscous sea deep within the planet. Their movement is extraordinarily slow, almost imperceptible on the scale of a human lifetime, or even many lifetimes. They creep along at speeds measured in centimeters, perhaps only an inch or two, per year. It's about the same speed that your fingernails grow, or a strand of hair lengthens. Imagine watching a continent drift. You wouldn't see it move in a day, or a year, or even a century. Standing on the shore, the ocean horizon would look the same tomorrow as it does today. The mountains inland would stand just as tall. Yet, over the vast stretches of geological time, millions upon millions of years, this infinitesimal creep adds up to journeys of thousands of kilometers. Continents that were once neighbors drift apart, oceans opening between them like slow, widening smiles. Landmasses that were once separated by vast seas are carried inexorably towards each other, eventually meeting in collisions so slow they take millennia to unfold, crumpling their edges like paper to raise majestic mountain chains. Think of the Atlantic Ocean. Today, it separates the Americas from Europe and Africa. But wind the clock back, far back into deep time, long before humans walked the Earth, and those continents were snuggled together, part of a single supercontinent. The Atlantic didn't exist. Then, the underlying puzzle pieces began to pull apart, slowly, centimeter by centimeter, century after century. Magma welled up from below into the widening gap, solidifying to create new ocean floor. The ocean basin grew, steadily, relentlessly, over tens of millions of years, pushing the continents further and further apart until they reached the positions we see on our maps today. And even now, as you lie sleeping, that ocean continues to widen, just a tiny fraction, adding infinitesimally to the distance between shores. Elsewhere, other pieces are moving towards each other. Imagine India, once an island continent drifting northward across a long-vanished ocean. For millions of years, it journeyed, carried on its tectonic plate raft. Ahead lay the immense landmass of Asia. The gap narrowed, slowly, inevitably. Then, the collision began. Not a sudden crash, but a gradual, irresistible pressure, buckling and folding the rock where the two plates met. Layer upon layer of crust was forced upwards, crumpled and stacked higher and higher over eons. This colossal, slow-motion impact created the Himalayas, the mightiest mountain range on Earth, lifting peaks into the freezing altitudes where clouds drift. Those mountains are still rising today, pushed incrementally higher by the continuing pressure, a testament to the immense power of these drifting puzzle pieces. Some plates slide past each other horizontally, grinding along vast fault lines. Think of the San Andreas Fault in California, a famous boundary where the Pacific Plate scrapes northwards against the North American Plate. The movement isn't always smooth. The immense friction between the rough edges of these colossal blocks of rock causes them to stick. Strain builds up, year after year, decade after decade, like bending a thick branch. Eventually, the strain becomes too great, and the rocks rupture, releasing the stored energy in a sudden jolt, an earthquake. For a few moments, the slow creep becomes terrifyingly fast, a reminder of the powerful forces constantly at work beneath our feet, usually operating on timescales too vast for us to notice directly. So, as you rest tonight, feel the stillness around you, but also, perhaps, hold in your mind this image of our planet's surface, a dynamic mosaic of giant, moving pieces. They glide and jostle, separate and collide, driven by the slow, deep heat and currents within the Earth's mantle. They carry the familiar shapes of our continents and the hidden depths of our oceans on an endless, silent journey. The ground beneath you isn't static. It's part of a plate, perhaps the North American, Eurasian, African, or another of the great slabs, inching its way across the globe. The mountains you might see in the distance, the shape of the coastline, the very ground your home is built upon, all are products of this slow, grand dance of the Earth's crust. This movement shapes everything. It dictates where oceans form and continents rift apart. It determines where volcanoes erupt, spewing molten rock from the depths, and where mountains rise towards the sky. It influences the distribution of minerals and resources within the crust. It even affects climate patterns over geological time as continents drift through different latitudes. Our sleepy planet, so seemingly peaceful on a quiet night, is actually a place of constant, profound transformation, driven by the relentless drift of these massive puzzle pieces. It's a process that happens largely unseen, unfelt, operating on a scale of time and size that dwarfs our everyday experience, yet it is fundamental to the character of the world we inhabit. The Earth is alive, not just with the life that crawls and flies and swims upon its surface, but with a deep, geological life of its own, a slow pulse measured in the drift of continents across millennia. And it continues, tonight, while you sleep, reshaping the world for futures unimaginably distant. The puzzle pieces continue their silent, inexorable journey across the deep, dark interior of our restless, sleepy planet. Let's linger for a moment longer with those immense puzzle pieces, those vast, moving segments of our planet's surface we spoke of just now. Picture them again, not just as flat shapes fitting together, but as something more substantial, something with depth and ancient character. Imagine them, if you will, as truly colossal rafts, floating silently on a hidden, deeper layer within the Earth. These aren't rafts made of wood or reeds, of course, but unimaginably enormous slabs of solid rock, thicker and more ancient than any human creation could ever be. They are the Earth's tectonic plates. Think of the grandest raft you can conjure in your mind, perhaps one large enough to hold a whole city, or even a small country. Now, expand that image. Stretch it outwards until it covers thousands upon thousands of miles, encompassing entire continents or vast stretches of the deep, dark ocean floor. These are the rafts we speak of, the tectonic plates. Some carry the familiar lands we know, the mountains, valleys, and plains of the continents, floating relatively high like thick, buoyant platforms made of lighter, older rock. Others form the bed of the vast oceans, thinner, denser rafts lying lower down, submerged beneath the world's waters. They fit together, side by side, covering the entire surface of our world, like the curved sections of a giant, rocky sphere. There are about a dozen major rafts, and many smaller ones, all jostling gently for position across the globe. Now, what are these immense rafts floating upon? It's not water, not in the way we usually think of it. Deep beneath the solid, rocky crust that forms the plates lies a layer unlike anything we experience on the surface. It's called the asthenosphere. Imagine a substance that is almost solid, yet capable of flowing, like extremely thick, warm honey, or perhaps slow-moving caramel just beginning to soften over a gentle heat. It's rock, yes, but rock under such tremendous pressure and temperature deep within the earth that it behaves like an incredibly viscous fluid over the vast timescales we're considering. It's not molten like lava erupting from a volcano. It's more like a solid that can deform and flow, slowly, ponderously, like glacier ice creeping down a valley, but driven by the planet's internal warmth. This deep, warm, yielding layer is the ocean upon which our giant rock rafts drift. The heat emanating from the Earth's core, a slow, steady warmth left over from the planet's formation and fueled by the decay of elements deep within, keeps this asthenosphere layer soft and pliable. Think of it as a vast, hidden cushion beneath the rigid plates. It's this softness, this ability to slowly flow and deform over millions of years, that allows the immense, rigid rafts of the lithosphere, the crust and the uppermost, solid part of the mantle fused together, to glide across the planet's surface. The rafts themselves, these tectonic plates, are fundamentally rigid. They are slabs of the lithosphere, which includes the crust, both the continental crust that makes land and the oceanic crust under the sea, and the very top, cooler, more brittle part of the mantle just beneath it. This combined layer, the lithosphere, is cooler and stiffer than the asthenosphere below. And because it's generally less dense, or at least arranged in a way that allows it to be supported by the denser, flowing material underneath, it floats. It's a delicate balance of temperature, pressure, and density. The cooler, harder rafts rest upon the warmer, softer, slowly flowing layer beneath. Imagine these rafts drifting in incredibly slow motion. Their journey is silent, measured not in miles per hour, but in inches per year, perhaps as slowly as your fingernails grow, or even slower. Across the span of a human lifetime, a plate might move only a few yards, a distance easily crossed in a couple of steps. It's a pace so slow, so gradual, that we cannot feel it beneath our feet. The ground feels perfectly still, solid, dependable. Yet, averaged over the immense expanse of geological time, millions upon millions of years, this minuscule creep adds up to colossal journeys. Continents that were once neighbors drift apart to form vast oceans between them. Ocean floors spread outwards from undersea ridges. Land masses collide, crumpling up like paper to form towering mountain ranges. Think of the North American plate, the vast raft carrying the continent you might be resting on now. It's slowly, steadily drifting westwards and slightly southwards, moving away from the Eurasian and African plates across the Atlantic Ocean. The Pacific Plate, the largest of all, forming much of the Pacific Ocean floor, is moving generally northwestwards. Each plate has its own direction, its own slow, ponderous trajectory across the yielding layer below. They are like colossal barges navigating an unseen, slow-motion current within the Earth's mantle. These rafts aren't uniform. The continental rafts, carrying land masses like North America, South America, Africa, Eurasia, Australia, and Antarctica, are generally thicker, perhaps 60 to over 120 miles thick. They are made of older, less dense types of rock, like granite. Because they are less dense, they float higher on the asthenosphere, forming the visible continents. Imagine them as thick, old wooden barges, weathered and carrying a heavy load, but buoyant enough to ride high. The oceanic rafts, which form the floors of the great oceans like the Pacific, Atlantic, and Indian Oceans, are quite different. They are much thinner, perhaps only 4 to 60 miles thick. They are made of younger, denser rock, primarily basalt, formed from cooled volcanic material welling up from below. Being denser, these oceanic plates float lower on the asthenosphere, creating the deep basins that hold the world's oceans. Think of these as thinner, heavier metal rafts, largely submerged beneath the waterline, carrying the weight of the deep sea above them. So, our planet's surface is a mosaic of these two types of giant rafts, constantly in slow, almost imperceptible motion. They slide past each other along great fault lines, sometimes catching and then releasing energy in earthquakes. They pull apart, allowing new, hot material from the asthenosphere to rise and create new oceanic crust, like fresh decking being added to the edge of a raft as it moves away from another. Or they collide, sometimes with one dense oceanic raft sliding beneath a lighter continental raft, diving back down into the warm, yielding mantle. Sometimes, two continental rafts collide, their lighter rocks unable to sink easily, causing them to crumple and buckle upwards, pushing skywards to form immense mountain ranges like the Himalayas. But all this happens with a slowness that defies our everyday perception. It's a process unfolding over epochs, driven by the slow, convective currents within that warm, gooey asthenosphere itself. Just as warm water rises and cooler water sinks in a gently heated pot, the warmer, less dense material deep within the mantle slowly rises, spreads beneath the plates, cools, and then slowly sinks again. This incredibly slow churning, like currents in a vast, thick, subterranean ocean, exerts a drag on the underside of the rigid plates, nudging them along on their timeless journeys. Feel the stillness around you once more. The quiet of the night, the solid ground beneath. It feels permanent, unchanging. Yet, deep below, the silent drift continues. The raft you are on, whether it carries a continent or sits beneath an ocean, is moving. It is part of this grand, slow dance. The heat from the Earth's core provides the energy, the yielding asthenosphere provides the medium for movement, and the rigid lithospheric plates are the passengers, the giant, floating rafts carrying the world we know across the deep interior of our living, breathing, slowly churning planet. It's a journey measured in eons, a testament to the immense, quiet power shaping the face of our world, even now, as you drift towards sleep. The rafts glide on, silent, immense, rearranging the map of the Earth in ways only the deepest spans of time can reveal. Now, let your awareness drift deeper still, sinking below the rafts, below the yielding softness of the asthenosphere, traveling down towards the very heart of our world. What fuels this immense, slow journey of the continents? What provides the tireless energy for this planetary reshaping? It is the Earth's own inner warmth, a profound heat held captive within its core and mantle, radiating outwards like the gentle warmth from a hearth long tended. Think of it as the Earth's warm, slow breath, an exhalation of heat from deep within that stirs the very foundations of the world. This heat is ancient, almost as old as the Earth itself. Some of it is leftover warmth from the planet's fiery birth, a time of cosmic collisions and unimaginable energy, when the materials that make up our world first gathered and compressed under their own immense gravity. Imagine that primordial heat, trapped deep inside, slowly, patiently releasing its energy over billions of years, like the cooling ember of a colossal fire banked deep underground. It's a warmth that remembers the chaos of formation, now settled into a slow, enduring radiance. But there's another source of warmth too, woven into the very fabric of the planet's rocky depths. Deep within the mantle and core, certain elements, remnants of exploded stars gathered into our world, carry within them a quiet instability. Over vast stretches of time, these elements slowly transform, releasing tiny packets of energy as they change. It's not a violent process, but a slow, steady release, like the faintest hum of energy, multiplied over immense volumes of rock and unimaginable spans of time. This gentle, persistent radioactive decay acts like a slow-burning internal furnace, constantly replenishing the heat within the Earth, adding to the primordial warmth. Together, these sources create a reservoir of heat, so vast it defies easy comprehension, a quiet powerhouse driving the slow life of the planet. This deep heat doesn't simply sit there, like the warmth from a stone placed near a fire. It seeks to spread, to move outwards from the intensely hot core towards the cooler surface. But the journey is incredibly slow, hampered by the sheer thickness and density of the overlying mantle. Imagine warmth trying to seep through a blanket thousands of kilometers thick. It travels not as a rush, but as a slow, pervasive diffusion, gradually warming the deep rock. And as this heat permeates the mantle, it sets up the incredibly slow churning we spoke of earlier, those convection currents the Earth's deep breath made manifest. Rock, deep within the mantle, warmed by the proximity to the core or by the slow release of atomic energy, becomes ever so slightly less dense, slightly more buoyant than the rock above and around it. Think of a bubble forming, not of air in water, but of slightly warmer, more yielding rock within a sea of slightly cooler, stiffer rock. This difference is minuscule, almost imperceptible, but over the immense pressures and timescales of the deep Earth, it is enough. Slowly, inexorably, over millions upon millions of years, these zones of warmer rock begin to rise. Not like a boiling kettle, but with a majestic, unhurried ascent, perhaps moving only centimeters a year, or even less. It's a movement so slow, it makes glaciers seem like rushing rivers. Picture vast, continent-sized plumes of warmth, gradually ascending through the viscous mantle, carrying heat towards the surface like slow, warm exhalations. As this warmer material rises and approaches the underside of the rigid lithospheric plates, our rafts, it spreads out laterally, like smoke flattening against a ceiling. Having traveled far from the deepest heat source and being closer to the cold of space radiating down through the crust, this material begins to lose its warmth. It cools, gradually becoming denser, heavier. And just as the warmer rock rose, this now cooler, denser rock begins the equally slow journey back down. It sinks gently, drawn by gravity back towards the depths, displacing more heated rock, which in turn begins its slow ascent. It's a cycle of profound slowness, a circulation within the Earth's mantle, operating on timescales that dwarf human history. A single cycle, a full turnover of this deep, warm breath, might take hundreds of millions of years to complete. It's a rhythm set not by days or seasons, but by geological epochs. This immense, slow circulation, this deep breathing of the Earth, is what gently nudges the tectonic plates floating above. The rising and spreading currents exert a subtle drag on the underside of the lithosphere, like a vast, slow-moving river pulling at the keel of an enormous barge. The sinking currents, elsewhere, might pull the edge of a plate downwards, drawing it back into the mantle's embrace. It's not a forceful shove, but a persistent, irresistible persuasion, acting over millions of years. The heat provides the energy, the convection currents translate that energy into motion, and the plates respond, gliding almost imperceptibly across the softened layer of the asthenosphere. The asthenosphere itself owes its unique properties to this deep heat. It's not molten like lava, but it's warm enough, under enough pressure, that the rock minerals are close to their melting point. This makes the rock capable of slow, plastic flow over geological time. Think of extremely stiff putty or wax left in the sun for a very long time. It can yield, deform, and flow without breaking, providing that crucial slippery layer upon which the rigid plates can move. The heat from below keeps the asthenosphere soft and pliable, the perfect interface between the deep, churning mantle and the brittle, drifting rafts carrying the continents and oceans. Without this deep warmth softening the asthenosphere, the plates might be locked in place, the Earth's surface static and unchanging. Imagine now, as you lie still, the quiet, pervasive warmth deep beneath you. It's not a heat you can feel directly on your skin, of course. It's buried beneath kilometers of insulating rock and crust. But its influence is everywhere. It's in the slow separation of continents, the gradual widening of oceans. It's in the buckling of land masses that raises majestic mountain ranges over eons. Occasionally, we get a more direct hint of this inner fire, the geothermal heat that warms hot springs, powers geysers, or is tapped by geothermal power plants. These are like tiny whispers, small clues to the immense thermal engine operating silently in the planet's depths. Even the dramatic eruption of a volcano is, in a way, a momentary, violent release of this deep heat and material, a brief glimpse into the processes that usually unfold with imperceptible slowness. But mostly, this heat works quietly, patiently. It doesn't roar, it breathes. A slow, warm, planetary respiration cycle measured in hundreds of millions of years. This breath shapes everything. It dictates where oceans will form and where mountains will rise. It drives the recycling of the Earth's crust, pulling old seafloor down into the mantle's depths to be reheated and renewed, while allowing new crust to form elsewhere. It is the ultimate source of the geological dynamism that makes Earth a living planet, constantly reshaping its surface features. Feel the stillness around you again, the quiet room, the steady presence of the ground beneath. It feels so solid, so permanent. Yet, powered by that deep, ancient warmth, the raft you are resting upon continues its infinitesimal drift. Millimeter by millimeter, year after year, century after century, millennium after millennium, the heat doesn't tire, the slow convection doesn't cease. The Earth breathes its warm, slow breath, and the continents journey onwards. This warmth is a fundamental aspect of our planet, as essential as its oceans or atmosphere. It's a reminder that the Earth is not just a solid ball of rock, but a dynamic system with a hot, active interior. This internal heat engine has been operating since the planet's youth and will continue for billions of years more, slowly but surely rearranging the cosmic furniture of our world's surface. So, as you drift closer to sleep, let your mind embrace this idea of deep, slow warmth. Picture the core like a distant, gentle sun buried at the center of the world. See the mantle stirred by its heat in currents, slower than drifting thoughts. Feel, in your imagination, the almost imperceptible movement of the vast plate beneath you, nudged along by this patient, planetary warmth. The Earth's slow breath continues, a silent, powerful rhythm beneath the quiet of the night, shaping the world that will greet you in the morning. A world sculpted by forces that operate on scales of time and temperature almost beyond imagining, all driven by the enduring heat held deep within its heart. It's a process of immense tranquility, a slow dance powered by the planet's own inner life, unfolding now, as it always has, in the profound quiet of the deep Earth. These immense rafts, these plates carrying oceans and continents, drift upon the deeper currents of the Earth's warmth with unimaginable patience. They float like colossal lily pads on a hidden, slow-moving pond, their journeys measured not in miles per hour, but in inches per year, slower than fingernails grow, slower than the quiet creep of moss on ancient stone. They are so vast, yet they move with a grace born of immense scale and time. But they are not solitary voyagers drifting forever apart on this deep, warm sea within the Earth. Like sleepy giants sharing a boundless fluid bed, their edges inevitably, eventually, meet. And it is here, at these meeting places, these boundaries where the Great Plates touch, that much of the Earth's surface finds its shape, its character, its mountains and valleys, its deepest trenches and newest lands. These interactions are not sudden collisions or violent encounters in our human sense of time. Rather, they are slow dances, quiet conversations between titans, unfolding over millions upon millions of years. Imagine, if you will, what happens when two of these great rafts drift, slowly, inexorably, towards one another. It's a coming together of immense consequence, yet it happens with the ponderous slowness of clouds merging on a windless day. Think of it not as a crash, but as a kind of planetary cuddle, a slow, deep embrace that reshapes the world. The nature of this embrace depends entirely on the rafts involved. Sometimes, a raft carrying a deep ocean floor drifts towards one bearing a lighter, thicker continent. The ocean plate, having traveled far across the cold seabed, is older, cooler, and denser than the buoyant landmass it approaches. As they meet, the ocean plate, with infinite slowness, begins to dip, to bow gently beneath the edge of the continent. This isn't a sharp dive, but a long, gradual descent, a quiet, yielding into the warmer, softer mantle below. This process, called subduction, is like one giant slowly tucking itself under the edge of another's blanket. Where the ocean plate bends downwards, it creates incredibly deep valleys in the sea floor, oceanic trenches, the deepest places on our planet, like quiet, dark folds hidden beneath the waves, places of immense pressure and profound stillness. As the descending plate sinks deeper into the Earth's warmth, the rock itself begins to weep, releasing water trapped within its minerals. This water lowers the melting point of the mantle rock above it, causing it to melt and form magma. This molten rock, lighter than its surroundings, slowly rises, seeking the surface. It may eventually push through the overlying continental plate, emerging far inland from the coast as volcanoes. But picture these not as sudden, angry eruptions, but as quiet sighs of heat from the deep earth, building gentle mountains over eons, mountains that sometimes breathe steam and ash, reminders of the slow digestion happening far below. What if two ocean rafts drift towards each other? Both are dense, both are cool. As they meet, one, perhaps slightly older and colder, will begin the same slow descent beneath the other. Again, a deep trench forms, marking the line of this slow underwater embrace. And just like before, the descending plate weeps water, triggering melting in the mantle above. But this time, the rising magma pushes through the overlying ocean plate. Reaching the cold seawater, it cools and solidifies, building underwater mountains. Over vast stretches of time, these mountains can grow tall enough to breach the surface of the ocean, forming chains of volcanic islands. Imagine them as strings of sleepy pearls rising from the blue island arcs born from the slow cuddle of two ocean plates, places like Japan or the Aleutian Islands, sculpted by this quiet, deep process. And then there is the most ponderous cuddle of all, when two rafts carrying continents slowly converge. Continents are thick, buoyant, and made of relatively light rock. Neither wants to dip beneath the other. Neither is dense enough to easily sink back into the mantle's embrace. So, as they push slowly, relentlessly against each other, there is nowhere for the rock to go but up. Imagine two immense, soft blankets being pushed together on a bed. They wrinkle, they fold, they crumple skywards. This is how the greatest mountain ranges on Earth are born. The Himalayas, the Alps, these are the magnificent, crumpled edges of continents locked in a slow-motion collision that has lasted for tens of millions of years. The pressure is unimaginable, the force is immense, yet the process is profoundly gradual. Rock folds like taffy, bends like plastic, and is thrust upwards millimeter by millimeter, year after year, creating soaring peaks and vast plateaus. It is a quiet testament to the immense power of slow, sustained pressure, a cuddle that raises land towards the heavens. But plates don't only move towards each other. Sometimes, these great rafts find themselves drifting gently apart. Imagine a quiet stretching, a slow exhale as space begins to open between them. This happens where underlying currents in the mantle are slowly diverging, gently pulling the overlying plates in opposite directions. Beneath the deep oceans, this stretching creates some of the most remarkable features on our planet, though hidden from our view. As the two ocean plates pull apart, the pressure on the underlying mantle lessens. Hot, soft rock from deeper within wells up passively to fill the growing gap. It's not an explosion, but a quiet upwelling, like honey rising slowly in a warmed jar. This molten rock, magma, reaches the seabed, cools rapidly in the cold water, and solidifies, forming new oceanic crust. This process is happening constantly, continuously, along vast underwater mountain ranges known as mid-ocean ridges. Picture a seam running down the middle of the great oceans, like the stitching on a baseball, where new ocean floor is perpetually being created. This is the Earth quietly knitting new surface for itself. These ridges are zones of creation, places like the Mid-Atlantic Ridge or the East Pacific Rise, where the planet gently stretches and renews its oceanic skin. Along these ridges, you might also find hydrothermal vents, like deep-sea chimneys releasing superheated water rich in minerals from below. Quiet exhalations of the planet's inner warmth into the cold, dark deep. This stretching doesn't only happen beneath the oceans. Sometimes, a continent itself begins to feel this slow, outward pull. The continental crust starts to thin, like dough being gently stretched. The land surface sags downwards, forming long, wide valleys, known as rift valleys. The East African Rift Valley is a place where this is happening right now, a continent slowly beginning to unzip itself. Volcanoes may appear along the rift, as the thinned crust makes it easier for magma to reach the surface. If the stretching continues for long enough, millions of years perhaps, the continent may tear completely apart. The valley floor could sink below sea level, allowing the ocean to flood in, creating a new, narrow sea between two separate landmasses. The Red Sea, separating Africa and the Arabian Peninsula, is an example of a young ocean basin formed by this slow continental stretching. It's the earth-making room, sighing and yielding over geological time to create new shapes, new seas, new coastlines. Finally, there is a third way these planetary rafts interact. Sometimes, they neither cuddle nor stretch. Instead, they simply slide alongside each other, moving in parallel but opposite directions, or in the same direction at different speeds. Imagine two enormous blocks of ancient ice drifting past one another on a slow-moving river, their edges scraping and grinding quietly in the current. These are transform boundaries. The movement here is horizontal, no crust is created, none is destroyed. The plates just quietly slip past their neighbor, but the edges of these plates are not smooth, perfectly straight lines. They are ragged, uneven, complex frontiers of rock. As they try to slide past each other, these rough edges catch, snag, and lock together. While the deeper parts of the plates continue their slow, inexorable drift, driven by the mantle's currents, the locked edges hold firm. Strain begins to build up along this locked section, like winding a giant spring tighter and tighter. The rock bends, storing energy, holding the tension in silence for years, decades, sometimes centuries. The pressure mounts, slowly, patiently, relentlessly. Then, inevitably, the accumulated stress overcomes the friction holding the rocks together. In an instant, the locked section ruptures. The plates suddenly slip, lurching past each other to catch up, releasing all that stored energy in a jolt that travels through the Earth's crust as seismic waves. This sudden release, this quick shudder through the rock before stillness returns, is what we experience as an earthquake. Places like the San Andreas Fault in California are famous examples of these transform boundaries, zones where the Earth holds its breath for long periods, building tension along the quiet line where two plates brush past, before releasing it in a sudden sigh, a brief shiver that reminds us of the immense, slow power constantly reshaping the world beneath our feet. The primary motion is the slow, steady slide. The earthquake is just a momentary consequence of the friction along the way. So, as you rest, picture these three fundamental ways the Earth's great rafts interact. See them slowly cuddling together, raising mountains to the sky, or dipping one beneath the other to recycle crust back into the deep earth, breathing volcanoes into existence. See them gently stretching apart, knitting new ocean floor along underwater ridges, or slowly tearing continents asunder to make way for new seas. And see them quietly sliding past each other, building silent tension along their shared edges before a sudden slip releases the strain. Each interaction, whether a cuddle, a stretch, or a slide, happens with a patience that dwarfs our human lifespan. Each is a part of the Earth's slow, rhythmic dance, driven by the deep, enduring warmth within its core. These are the processes that sculpt the landscapes we know, the mountains we see, the valleys we walk through, the oceans we sail upon, the very ground beneath us, all shaped by the quiet, immense, and ceaseless movements of the planet's tectonic plates, interacting at their edges in a slow ballet of creation and transformation that continues, even now, as the world sleeps. Let us now turn our attention more closely to one particular kind of interaction, one specific way these great rafts of crust choose to meet. We spoke of them cuddling together, a gentle word for an encounter of truly planetary scale. Imagine two of these immense continents, perhaps carrying forests, deserts, rivers, and sleeping cities on their backs, drifting slowly, inevitably, towards each other across the face of the globe. Their journey has taken millions upon millions of years, propelled by the deep, slow currents within the Earth's mantle, those unseen rivers of heat and softened rock. They are like two ancient vessels, sailing on a sea of time, destined for a rendezvous of monumental consequence, yet conducted with the quiet patience of geology itself. Unlike the meeting where one plate dips beneath another, recycling itself into the fiery depths, sometimes the two approaching plates are of similar character, similar buoyancy. Think of them as two great, thick slabs of cork floating on water. When they meet, neither one is easily forced beneath the other. They are both too light, too buoyant relative to the denser mantle beneath them. So, As the relentless push from behind continues, urging them forward centimeter by slow centimeter, year after patient year, they meet edge to edge. There is nowhere else to go. They cannot dive down easily. They cannot simply slide past each other along this entire front. The only way to accommodate the continued movement, the ceaseless pressure, is upwards. Picture now, if you will, a very large, very soft, perhaps slightly heavy blanket, spread out smoothly upon a vast bed. It represents the layers of rock that make up the Earth's crust, laid down over countless ages, sediments settled in ancient seas, flows of volcanic rock cooled and hardened, older rocks transformed by heat and time. Now, imagine placing your hands flat on opposite sides of this blanket, quite far apart, and beginning to push them slowly, steadily, towards the center. What happens? The smooth surface begins to yield. Gentle swells appear, rising softly from the flat expanse. As you continue to push, ever so slowly, these swells become more pronounced, turning into distinct wrinkles, folds that ripple across the fabric. Where the blanket compresses, it buckles upwards, creating ridges and valleys in the soft material. It doesn't tear or shatter. The slow, steady pressure causes it to deform, to fold upon itself, accommodating the shrinking space by rising towards the sky. This is remarkably similar, in a gentle, simplified way, to what happens when two continental plates converge. The forces involved are, of course, unimaginably vast, exerted not by hands but by the slow, powerful drift of entire continents driven by the Earth's inner heat. The blanket is the Earth's crust, kilometers thick, composed of rock that seems utterly solid and unyielding to us in our fleeting human experience. Yet, under the immense, sustained pressure of colliding continents, and over the almost incomprehensible expanse of geological time, this rock behaves differently. Deep within the crust, where temperatures and pressures are higher, the rock doesn't just fracture, it can slowly bend, deform, and fold. Much like extremely stiff clay, or plasticine being patiently squeezed, it yields not in moments, but over millennia. As the two continental plates push against each other, the layers of rock caught in the middle begin to buckle and warp. Flat-lying beds of sandstone, shale, and limestone, deposited perhaps in ancient, shallow seas long vanished, are slowly compressed. They begin to arch upwards into broad curves called anticlines, like the crests of the waves in our blanket analogy. Between these upfolds, the rock layers bend downwards into corresponding troughs, known as synclines. Imagine the slow-motion crumpling of a colossal sheet of layered stone. The pressure is relentless, the movement infinitesimal year by year, but the cumulative effect over millions of years is profound. These folds don't just form and stop. As the continents continue their slow-motion collision, the initial folds become tighter, more pronounced. Older folds might be pushed up and over younger ones, stacking layers of deformed rock upon each other. This process, known as folding and thrust faulting, where slices of crust are pushed over neighboring slices, effectively shortens the crust horizontally, like pushing the edges of the blankets together, and thickens it vertically. The land surface, caught in this immense, slow squeeze, has no choice but to rise. And so, mountains are born, not in sudden, violent upheavals, but through this incredibly slow, patient process of wrinkling and thickening the Earth's crust. Think of the great mountain ranges of the world, the Himalayas, the Alps, the Appalachians. These are not merely piles of rock, they are vast, complex structures formed by the folding and faulting of the crust under unimaginable compressive stress. The parallel ridges and valleys that often characterize such ranges are the surface expression of the underlying anticlines and synclines, the giant wrinkles formed in the continental collision zone. Standing amongst them, you are standing within the fabric of a crumpled continent. The Himalayas, for instance, the highest mountains on our planet, are the result of the ongoing collision between the Indian plate and the Eurasian plate. India, once an island continent, drifted northwards for tens of millions of years until it began to collide with Asia perhaps 50 million years ago. It's a process that continues even today. The immense height of the Himalayas is a testament to the sheer scale and duration of this continental embrace. The rock layers that form Mount Everest and its neighbors were once sediments lying flat beneath an ancient sea called the Tethys. Now, squeezed, folded, and thrust upwards by the relentless push of India into Asia, they reach towards the stratosphere. This process of mountain building is profoundly slow. The plates might move towards each other at a rate comparable to how fast your fingernails grow, just a few centimeters per year. To raise mountains kilometers high takes millions upon millions of years. It happens on a timescale so vast it's difficult for us to truly grasp. While we live our lives, build our cities, and watch seasons turn, these mountains are imperceptibly, steadily rising. They seem to us the very definition of permanence, of stillness, yet they are dynamic structures, actively growing or slowly eroding, shaped by forces operating on a planetary scale over deep time. This is why we might think of them as sleepy mountains. Their birth and growth occur in a profound slumber, a slow-motion ballet of geological forces unfolding over eons. They rise not with a roar, but with a quiet, inexorable swelling. The immense pressures build silently within the rock. The folding happens deep beneath the surface, hidden from view, revealed only as erosion later sculpts the uplifted land. The upward movement is so gradual, so patient, that it feels like stillness itself. These mountains are like ancient giants, breathing slowly, their chests rising almost imperceptibly over countless millennia. Furthermore, just as the wrinkled blanket bunches up, becoming thicker in the folded region, the Earth's crust thickens significantly beneath these great mountain ranges. The continental crust, normally perhaps 30 to 50 kilometers thick, can reach depths of 70 kilometers or more under major mountain belts. These deep extensions of lighter crustal rock into the denser mantle below are often called mountain roots. Like the hidden bulk of an iceberg beneath the water, these roots provide buoyant support for the immense weight of the mountains above. They are part of the isostatic balance, the equilibrium that the Earth's crust seeks with the underlying mantle. So, when you gaze upon a mountain range, see more than just peaks and valleys. See the result of a slow, patient convergence, an ancient meeting place of continents. See the wrinkles in the Earth's crust pushed up over millions of years by forces deep within the planet. Imagine the layers of rock, once flat, now folded and tilted, telling a story of immense pressure and unimaginable time. Feel the quiet majesty of these sleepy giants, born not of haste, but of the Earth's enduring, slow-motion embrace. They stand as silent, serene monuments to the power of persistence, the profound transformations wrought by the gentle, ceaseless dance of the tectonic plates, pushing together, wrinkling the land, and lifting the crust towards the quiet stars, all while the world rests. The very ground that seems so solid, so permanent, is merely a snapshot in a long, slow story of change, a story written in folds of rock, rising softly over ages. But the Earth's slow dance isn't only about coming together, about the gentle, persistent pressure that folds and lifts the land into sleepy mountain giants. There is another movement, equally profound, equally patient, that unfolds in the planet's hidden depths. It is a movement not of convergence, but of quiet separation, an easing apart, like a slow, deep stretch after a long stillness. Imagine the planet itself taking a slow, silent yawn, not in the air, but deep beneath the vast, dark waters of its oceans, making room. This is how new oceans are born, and how existing ones widen, breath by steady breath, over immense spans of time. Where the continental plates pull together and thicken the crust, there are other places where the great tectonic plates are slowly, inexorably drifting away from each other. This movement doesn't begin with a sudden, violent tearing, but rather with a subtle, deep-seated tension. Picture the solid, yet fundamentally fluid, rock deep within the Earth, feeling a gentle, persistent pull in opposite directions. This isn't a sharp tug, but a slow, steady draw, like easing apart two pieces of soft clay that have rested together for a long time. Initially, the crust, subjected to this quiet tension, begins to thin. It doesn't snap, it stretches, like warming taffy pulled slowly. On the surface, perhaps millennia pass with little visible change, just a gradual subsidence, a slight sagging of the land over a wide area. The rock below, under immense pressure and warmth, behaves not as the brittle substance we know on the surface, but as an incredibly viscous fluid, yielding patiently to the enduring pull. If this stretching begins beneath a continent, long, shallow valleys may begin to form, tracing the line of this nascent separation. These are rift valleys, nascent scars where the continent is beginning to contemplate dividing. They might appear as gentle depressions at first, perhaps cradling long lakes or slow-moving rivers, unaware of the profound separation beginning far beneath them. The land simply eases downwards, making a subtle hollow. If this gentle stretching continues, if the pull persists over millions of years, the crust thins further still. It becomes fragile along this line of tension. Eventually, deep fractures may reach down towards the hotter, softer mantle below, and as the two sides continue their slow drift apart, a gap begins to open, a space created where solid land once was. If this rift valley is near the coast, or if it deepens sufficiently, the ocean itself may eventually find its way in. Not as a sudden flood, but perhaps as a slow creep, a tongue of seawater exploring the newly formed depression, gradually filling it over centuries, creating a narrow inland sea, a young ocean in the making, like a slender inlet reaching deep into the land. But the most profound expression of this quiet separation happens far from continental shores, hidden beneath kilometers of dark, cold water, on the floor of the vast, established oceans. Here lie the mid-ocean ridges, the longest mountain ranges on Earth, yet entirely submerged, tracing enormous paths across the globe like seams on a well-worn ball. These are not jagged peaks like the Himalayas or the Alps, born of compression. Instead, they are broad, gently swelling rises, underwater highlands that mark the very places where the oceanic plates are actively moving apart. They are the center stage for the Earth's quiet act of creation. Imagine yourself sinking slowly through the immense, silent water column, down, down, into the crushing pressure and absolute darkness of the abyssal plain. Leaving the sunlit world far behind, you descend into a realm of perpetual night, where the only light comes from the occasional bioluminescent creature flickering past. The water is near freezing, the pressure immense. And yet, here, along the crest of these immense, unseen ridges, the Earth is warm. Here, the oceanic crust, already thinner than its continental counterpart, is being gently pulled apart. As the plates ease away from each other, millimeter by patient millimeter, year after year, they don't leave an empty void. From the asthenosphere below, that layer of the upper mantle that is hot, soft, and capable of slow flow, warmer material wells up to fill the space. This isn't a violent volcanic eruption in the way we often picture it, not an explosion of ash and fire into the air. Instead, think of it as a slow, steady upwelling, a persistent seep of molten rock, magma, rising passively into the narrow crack created by the separating plates. It's like honey slowly filling a gap between two slices of bread being gently pulled apart. This magma, originating from the partial melting of the mantle rock below, is basaltic in composition, denser than continental rock, richer in iron and magnesium. As this dark, molten rock reaches the seafloor, or the near surface within the rift, it meets the frigid, deep ocean water. The intense cold causes the outer surface of the magma to chill rapidly, solidifying almost instantly into a glassy or finely crystalline rock, pillow basalts, often forming rounded, bulbous shapes as the molten material oozes out and quickly skins over in the cold water, looking like piles of soft cushions strewn across the seafloor. Deeper within the fissure, the cooling is slower, allowing slightly larger crystals to form, creating layers of gabbro. This newly solidified rock becomes the fresh edge of the separating plates. It is brand new seafloor, knitted quietly into existence in the deep, dark silence. This process is continuous. As soon as one sliver of new crust forms, the persistent pulling apart of the plates moves it sideways, making way for more magma to well up behind it. It's a geological conveyor belt, operating on an unimaginable timescale. The mid-ocean ridge is the source, the place of birth, and the new ocean floor journeys slowly away from it, pushed aside by the constant arrival of younger material. Like ripples spreading outwards from a disturbance in water, the seafloor spreads away from the ridge crest. So, If you could sample the age of the rocks across the ocean floor, you would find a beautiful, symmetrical pattern. The youngest rocks, freshly minted, are found right at the very crest of the mid-ocean ridge. As you move away from the ridge, either to the east or to the west, the rocks become progressively older. Meters turn into kilometers, years into millions of years. The seafloor holds a silent record of its own creation, with the age stripes running parallel to the ridge axis. The oldest ocean floor lies furthest from the ridges, often near the edges of continents, waiting perhaps for its eventual return into the mantle at a subduction zone, completing another part of the Earth's slow cycle. This entire process, this gentle widening of the oceans, happens in profound quietness and darkness. The immense pressure of the overlying water dampens any sound, muffles any vibration. The creation of vast swathes of our planet's surface occurs unseen, unheard, driven by the slow, steady convection currents deep within the mantle, those same currents that push continents together in other parts of the world. Here, they are pulling them apart, allowing the Earth to exhale, to stretch, to make new skin. Think of the mid-ocean ridge not as a wound, but as a seam of creation, a place where the planet perpetually renews its oceanic crust. It is a slow, warm breath in the cold, dark, deep. The heat escaping from the Earth's interior along these ridges also supports unique ecosystems, clustered around hydrothermal vents, fissures where superheated, mineral-rich water jets out from the young crust, feeding bizarre communities of life that thrive without sunlight, relying instead on chemical energy. Even here, in this seemingly remote and extreme environment, life finds a way, sustained by the planet's inner warmth, leaking out along these zones of gentle separation. So, while the continents may slowly collide, wrinkling and thickening to raise mountains towards the sky, the ocean basins are engaged in a different kind of slow transformation. They are widening, expanding, as new floor is paved strip by silent strip along the mid-ocean ridges. It is the Earth making room for itself, a quiet, steady expansion driven by the relentless, patient drift of the plates. It's the other half of the dance, the easing apart, that balances the coming together. See the vastness of the ocean not just as a surface of water, but as a covering for this immense slow-motion act of creation happening constantly beneath. Feel the quiet expansion, the Earth's deep, slow yawn beneath the waves, stretching out over aeons, shaping the silent, hidden landscapes of the deep sea floor, a testament to the planet's ceaseless, peaceful becoming. The solid ground beneath the waves is young, constantly renewed, a reminder that even in the deepest, darkest corners of our world, the Earth is never truly still, but always breathing, always shifting, always gently remaking itself. And just as the Earth breathes out slowly along those vast undersea seams, creating new floor for the oceans, its deep, quiet warmth sometimes finds other pathways, other little places to touch the world above. Imagine that immense, gentle heat deep beneath our feet, the same heat that drives the slow dance of the continents and the widening of the sea floor. Sometimes, this warmth gathers, not along a lengthy ridge, but more like a focused sigh, finding a weakness, a tiny channel, a patient route upwards through the many layers of rock that make up the Earth's sturdy shell. These places, where the inner warmth concentrates and finds its way to the surface, are like the planet's little warm spots. We call them volcanoes. Perhaps the name sounds fiery, but think of them first as just openings, connections between the deep, molten heart of the Earth and the cool air or water above. They are vents, chimneys, places where the planet lets off a little steam, shares a little of its internal heat. Deep down, where the pressure is immense and the temperatures are high enough to soften stone, rock can exist not as the solid stuff we walk on, but as a thick, glowing liquid, like incredibly hot honey or molasses. This molten rock, called magma while it's still beneath the surface, is often slightly lighter, slightly more buoyant than the solid rock surrounding it. And so, very, very slowly, almost imperceptibly, plumes or pockets of this warmth begin to rise. It isn't a violent surge, not usually. Think more of a warm bubble rising slowly through cooler oil or the way warm air drifts upwards on a still day. It seeks the path of least resistance, winding its way through cracks and fissures, melting its way patiently through the overlying rock, inching closer to the world we know. This journey can take thousands, even millions, of years. It is a slow, persistent migration of heat, carried within the molten rock, moving towards the coolness of the surface. As it gets closer, the pressure lessens. Gases that were dissolved within the magma, held tight by the immense pressure deep below, begin to gently separate, forming tiny bubbles, like fizz in a warm drink that's been opened. This makes the magma even lighter, encouraging its slow ascent. Eventually, after its long, quiet journey, this pocket of warmth might reach the surface. It might find an opening, a place where the crust is thin or already fractured. And then it emerges. The magma, now flowing out onto the surface, is called lava. It spills out, not always in a great rush, but sometimes as a gentle overflow, a release. Imagine thick, dark treacle pouring slowly from a jar. The color is often dark, almost black when it first emerges, but it glows with the intense heat it carries from deep within. Reds, oranges, yellows, a visible reminder of the Earth's inner fire, now breathing out into the open. This lava, this messenger from the deep, flows across the land or onto the seabed. It moves slowly, relentlessly, covering what lies beneath. As it meets the cooler air or water, its surface begins to cool rapidly. It forms a skin, a crust, much like the skin on cooling custard. This skin might wrinkle and fold as the molten river beneath continues to move, creating ropey textures, like coils of thick, dark rope laid across the landscape. Or, if the flow is broken or more fragmented, it might cool into rough, clinkery blocks, tumbling over each other with a gentle, glassy chime as the flow advances. Beneath this cooling crust, the inside of the flow remains liquid and hot for longer, insulated by the hardening shell. Sometimes, the liquid lava inside drains away after the surface is solidified, leaving behind an empty tube, a cave formed of cooled rock, a secret tunnel marking where the warm river once flowed. Each flow, once it finally comes to rest and cools completely, becomes new rock, new land. It is a thin layer, perhaps just a blanket spread over the older surface. But the Earth is patient. Another pulse of warmth might find its way up the same pathway, years or centuries or millennia later. Another flow spills out, covering the first. Layer upon layer, flow after flow, the land begins to grow. Think of candle wax dripping down the side of a candle, each drop cooling and solidifying, slowly building up a thicker and wider base. The volcano grows in a similar way, built not of wax, but of cooled and hardened rock. If the lava is very fluid, like thin syrup, it can flow for great distances before it cools. Repeated flows of this type don't build a steep mountain, but rather a vast, gently sloping shield, like the shape of an ancient warrior's shield laid flat upon the ground. These shield volcanoes, often found rising from the deep ocean floor, are some of the largest mountains on Earth, measured from their base, hidden beneath the waves. The islands of Hawaii are just the very tops of enormous shield volcanoes, built up over millions of years by countless quiet overflows of lava from a persistent warm spot deep beneath the Pacific Plate. Imagine these islands, green and alive now, born layer by patient layer from the Earth's deep warmth, rising slowly from the sea. Each dark layer of rock visible in a cliff face is a memory of a time when the warmth surfaced, spread out, and cooled, adding its small contribution to the growing land. Other times, the magma might be thicker, stickier, or carry more trapped gas. When this reaches the surface, the release might be less of a gentle spill and more of a frothy outburst. The trapped gases expand rapidly in the lower pressure of the surface, creating bubbles that burst, throwing fragments of molten and cooling rock into the air. These fragments, from fine ash like dark flour to larger chunks called cinders or bombs, fall back to Earth around the vent. They build up a cone shape, often much steeper than the gentle slopes of a shield volcano. Even this, though, is a form of construction. The ash settles like a strange, dark snowfall, blanketing the landscape. Over time, this ash breaks down, weathering into incredibly fertile soil, a gift from the Earth's depths that allows life to flourish anew. The cone itself is new land, piled high by the Earth's exhalation. So, these warm spots, these volcanoes, are not just interruptions or disruptions, they are also places of creation. They are points where the substance of the deep Earth is brought to the surface, adding to the continents, building islands where there was once only water. They are tangible proof of the planet's inner life, its restless, simmering heat finding expression. See the dark, hardened lava fields not as scars, but as fresh canvases, new ground waiting for time, weather, and life to soften its edges and make it home. Feel the gentle warmth that still radiates from some young volcanic rocks, a lingering reminder of their fiery birth. These spots can occur in different settings. Some volcanoes line up along the edges of tectonic plates, particularly where one plate is diving beneath another. As the descending plate sinks back into the hotter depths, water trapped within its rock is released. This water lowers the melting point of the overlying mantle rock, allowing magma to form and rise, creating chains of volcanoes on the overriding plate, like the Andes Mountains or the islands of Japan. Here, the volcanoes are a direct consequence of the plate's slow collision and descent. But other warm spots seem to appear far from the plate boundaries, right in the middle of a vast tectonic plate. These are thought to be caused by particularly persistent plumes of extra-hot material rising from very deep within the Earth, perhaps from the boundary of the core itself. These hotspots stay in roughly the same place for tens of millions of years, while the tectonic plate drifts slowly overhead. As the plate moves, the hotspot effectively punches a series of volcanic holes through it. The result is a chain of volcanoes, like the Hawaiian Islands and the Emperor Seamounts that stretch away from Hawaii across the Pacific floor. Only the volcano currently sitting over the hotspot is active, building new land. The older volcanoes, carried away from the hotspot by the moving plate, become dormant, slowly eroding back into the sea. It's like moving a piece of paper slowly over a lit candle. The candle stays still, but burns a line of marks across the moving paper. This chain is a silent record of the plate's slow, steady journey over the deep, anchored source of warmth. Whether they occur at plate edges or in the middle of plates, these volcanic warm spots are part of the Earth's continuous process of renewal and reshaping. They are pinpoints where the planet's internal energy becomes visible, tangible building material. While the mid-ocean ridges create vast expanses of new seafloor in the quiet depths, volcanoes build upwards, sometimes reaching towards the sun, creating mountains and islands, adding punctuation marks of new land to the Earth's surface. Think, then, of a volcano not primarily as a mountain of fire, but as a place where the Earth is slowly, patiently adding to itself. Imagine the deep, slow pulse of warmth rising, the gentle spill of lava adding another thin layer, the steam rising like breath into the cool air. See the dark rock as the newest skin of the planet, still warm perhaps, a testament to the enduring heat within. These little warm spots are reminders that the creation we saw happening silently beneath the oceans also happens right here on the surface, sometimes quietly, sometimes with a sigh of released pressure, but always contributing to the ever-changing, ever-becoming landscape of our world. It's another part of the planet's slow, rhythmic breathing, a focused exhale of warmth that builds, shapes, and renews the ground beneath our feet, one layer of cooled rock at a time. Feel the deep, steady warmth of the planet, not as a threat, but as the quiet engine of creation, gently sculpting our world from the inside out, even through these focused points of release. The Earth is alive, not just with water and wind and biology, but with this deep, stony warmth that finds its way out, building the world anew. Just as the planet exhales its inner warmth through those focused points of volcanic creation, building the land layer by patient layer, it also shifts and settles in other ways. Imagine the Earth's surface not as a single, solid shell, but as being composed of immense, continent-sized rafts floating and drifting almost imperceptibly upon a deeper, softer layer. These rafts, the tectonic plates we spoke of, are unimaginably vast and heavy, moving with a slowness that makes glaciers seem hasty. Think of the pace of your own fingernail growing. That's akin to the speed at which some of these colossal rafts drift across the planet's face, carrying oceans and continents upon their backs. Now, picture these enormous rafts meeting edge to edge. It's rarely a perfect fit, like trying to slide two pieces of rough, unfinished wood past each other. Their edges are jagged, uneven, immensely strong. As they are pushed by the slow, deep currents within the earth, they press against one another. For years, decades, even centuries, they might push, leaning into each other with incredible force, but locked in place by friction. The pressure builds, silently, steadily, deep within the rock. It's like holding your breath, feeling the tension gather, or the slow, steady tightening of a coiled spring, wound tighter and tighter over immense stretches of time. It's a quiet storing of energy along these vast seams in the Earth's skin. Nothing seems to happen on the surface. The mountains stand still, the plains stretch out peacefully, the oceans lap at the shores. But deep below, where the edges of these giant rafts grind together, the strain accumulates. It's a patient standoff, a contest of immense forces held in check by the stubbornness of rock. The energy increases incrementally, year after year, century after century, until finally, something has to give. The friction that held the rocks locked together is overcome by the relentless building pressure. And then, the Earth settles. It's not always a violent rupture, but often more like a sudden release, a quick adjustment. Think of it as a tiny shiver running through the planet's great body. Imagine lying very still for a long time, perhaps drifting towards sleep, and feeling a muscle finally release a cramp with a quick, involuntary twitch. Or picture a large log shifting slightly in a cooling fireplace, settling into a more stable position with a soft groan or crackle. That's akin to what happens along these fault lines. The locked rocks suddenly slip, just a little, perhaps only a few inches, or maybe several feet, along a stretch of the boundary. This sudden slip releases the stored energy. It travels outwards from the point of release, moving through the solid rock of the planet like ripples spreading across a still pond when a pebble is dropped in. These ripples are waves of energy, vibrations traveling through the Earth's crust. When these waves reach the surface where we live, we feel the ground move. This is the earthquake, the planet's gentle shiver made manifest. Often, these adjustments are so small, so deep within the Earth, that we don't feel them at all. Instruments can detect them, tiny murmurs in the planet's deep sleep, but life on the surface continues undisturbed. The Earth is constantly making these minute readjustments, settling itself countless times a day all across the globe, like someone finding a more comfortable position in a deep slumber. These are the quiet creaks and groans of a colossal structure settling under its own immense weight and slow movement. Sometimes, the shiver is more noticeable. It might feel like a deep rumble, less a sound heard with the ears and more a vibration felt through the soles of the feet or through the chair you sit upon. It might sound like the distant passing of a heavy train, a low, resonant hum that rises and falls quickly. The ground might sway gently for a few moments, a subtle rocking motion, as if the land itself were briefly remembering its fluid origins. Pictures on the wall might tilt slightly, or the water in a glass might tremble. It's the briefest of reminders that the ground beneath us isn't entirely static. It's part of a dynamic, shifting system. Think of the scale. We stand upon these vast rafts, tiny figures on immense surfaces. A movement that might shift the ground beneath our feet by several inches, perhaps causing buildings to sway, is, from the perspective of the entire plate, a minuscule adjustment along a boundary hundreds or thousands of miles long. It's like smoothing out a tiny wrinkle in a blanket that covers an entire room. The energy released can be significant locally, but for the planet as a whole, it's just a brief release of built-up stress, a way for the massive plates to accommodate the slow, relentless push from beneath and behind. These shivers are the inevitable consequence of the plate's slow dance. If the continents are to drift, if oceans are to open and close over millions of years, then the boundaries where these immense pieces meet must accommodate this movement. Sometimes they slide past each other relatively smoothly, with frequent, small adjustments. Other times, they lock together, building stress for longer periods, leading to more significant releases when they finally slip. But either way, the movement, the settling, the shiver, is part of the fundamental process of plate tectonics. It's the noise the machinery makes as it slowly, inexorably reshapes the world. It's easy to focus on the immediate effects, the shaking ground, but try to feel the deeper process. Feel it as the Earth finding a slightly better fit between its enormous moving parts. It's the planet adjusting its posture, releasing a bit of stiffness in its rocky shoulders. The shiver passes, the vibrations fade, and the rocks settle into their new position, perhaps slightly less strained than before, ready to begin the slow process of building stress anew, or perhaps ready for a period of quieter adjustment. This process isn't inherently about destruction. It's about adjustment and accommodation on a planetary scale. It's the way the Earth manages the immense forces involved in moving continents and ocean floors. Just as the volcanoes are points where the Earth builds and renews itself with heat from within, these shivers are moments where the Earth adjusts its vast, rocky skin, allowing the slow drift to continue. They are the counterparts to the slow creation, the necessary settling that accompanies the grand, silent movements shaping our world. So, feel the stillness that returns after the ground has trembled. Sense the immense quiet of the deep rock, the slow, steady pressure that continues its work, unseen and unfelt for long stretches of time. These moments of movement are just brief interruptions in the Earth's otherwise slow and patient geological rhythm. They are the planet's gentle shivers, tiny adjustments in the grand scheme, reminders that the solid ground is part of a living, breathing, slowly shifting world, constantly seeking balance, constantly adjusting, settling itself quietly in the vastness of time and space. The Earth sighs, settles, and the slow dance continues. And so, the slow dance continues, the Earth breathing in long, slow rhythms, measured not in seconds or seasons, but in ages stretching beyond our grasp. The settling shivers pass, and the deep quiet returns, a quiet that holds stories far older than any mountain range we know, any ocean we sail. Let your mind drift now, float back on the currents of this immense quiet, further and further back, past the time of ice ages, past the age of giant ferns and dinosaurs, back into a time so deep it feels like the Earth's own dream time. Imagine a time when the world felt different, not just older, but arranged in a way that seems almost like a forgotten memory held deep within the planet's core. Picture the continents, the familiar shapes we see on maps: Africa, the Americas, Australia, Eurasia, Antarctica, not scattered across the blue globe as they are now, but nestled together. Think of them like pieces of a giant, world-spanning puzzle, fitted perfectly edge to edge. Or perhaps, imagine them as sleepy kittens curled up together on a vast, warm hearth, sharing the planet's inner warmth. There were no wide oceans separating them then, no lonely islands adrift. All the major lands we know, and perhaps others now lost to time or changed beyond recognition, were gathered close, huddled together in one enormous embrace. This wasn't a crowded jumble, but a slow, peaceful gathering. A superland, a single immense continent stretching across a huge portion of the Earth's surface. Geologists, those who listen closely to the whispers of ancient rocks, call this dreamlike assembly Pangea, meaning all lands, or all Earth. Say the name softly to yourself. Pan, gay. Ah, it sounds like a lullaby sung by the stones themselves. Picture this immense landmass. Feel the warmth rising from its vast interior, far from any cooling sea breeze. Imagine plains stretching further than any eye could see, under a sky that perhaps held different clouds, different colors. Imagine ancient rivers, rivers of truly epic proportions, winding their slow way across thousands of miles of connected land, carrying sediments from highlands you wouldn't recognize towards shores that bordered not multiple oceans, but one single, colossal body of water. Think of the coastlines. Not the intricate, fractured edges we see today, carved by millennia of separation and shifting seas, but grand, sweeping curves where the unified land met the immensity of the single world ocean. Imagine standing on such a shore, the breeze carrying the scent of an ocean that touched every edge of the known world, an ocean called Panthalassa, the All-Sea. Feel the gentle lapping of waves against shores that belonged, in a way, to everywhere and nowhere specific, shores that were part of one continuous, planetary edge. There were no Atlantic, no Pacific, no Indian Oceans as we know them, just this one vast, seemingly endless expanse of blue water cradling the single great land. In this time of Pangea, the Earth's pulse might have felt different. Perhaps the planet breathed more slowly, its landmasses locked in a quiet embrace. The slow drift, the tectonic dance, was still happening deep below, the currents within the Earth's mantle still swirling like thick honey, but on the surface, there was a sense of wholeness, of temporary completion. The mountains that existed then were not the Himalayas or the Andes or the Rockies. They were older ranges, perhaps worn down by unimaginable lengths of time, or perhaps thrust up where different pieces of the supercontinent had gently bumped and wrinkled together long before. The familiar contours of our modern world were hidden, folded away within this grand, unified shape. South America tucked snugly against Africa's side, North America nestled beside Europe, Antarctica and Australia and India clustered together like buds on a single stem. It requires a kind of quiet listening to even begin to imagine this. Our own lives, even the recorded history of humankind, are like the briefest flicker of a firefly's light compared to the eons during which Pangea existed, and the even longer eons it took for the lands to drift together to form it. Think of the slowest, most patient processes you know. A tree growing, a canyon being carved by a river. Now, imagine processes infinitely slower, movements so gradual they are imperceptible, except over millions upon millions of years. This was the pace at which the Earth gathered its lands together into Pangea. It was a slow planetary nesting, a drawing in that took longer than we can truly comprehend. Feel the stillness of that ancient world. Perhaps the winds blew differently across such a vast, unbroken landmass. Perhaps the climates were arranged in broad, simple bands, unlike the complex patterns created by today's scattered continents and oceans. Vast deserts might have dominated the interior, far from the moisture of the single great ocean. Lush, damp regions might have fringed the immense coastline. The very air might have felt thicker, quieter, holding the hush of ages. Try to picture the rocks beneath your feet, wherever you are now. Imagine them connected, part of an unbroken chain stretching across lands now separated by vast seas. The granite of a mountain in Scotland might hold a memory of being joined to a mountain in Greenland or North America. The red earth of Brazil might whisper a tale of resting beside the soils of Nigeria. These are not just fanciful thoughts. The rocks themselves hold the clues. They show matching layers, like torn edges of a single piece of paper. They contain fossils of ancient plants and creatures that could only have existed if they could walk or spread freely across lands that are now oceans apart. The Earth remembers Pangea in its very substance. This wasn't a static world, even in its togetherness. The slow, deep breathing of the planet continued. The heat from within, the engine driving the tectonic plates, was still building. Imagine, deep beneath the surface of Pangea, a slow, almost imperceptible stirring, like a giant sleeper beginning to shift in a long slumber. The forces that had drawn the lands together were still at work, but perhaps changing direction, building pressure in new ways. The unity of Pangea, magnificent as it was, held within it the seeds of its own eventual separation. The slow dance was preparing for a new movement, a gradual, inevitable parting. But for a vast stretch of time, this superland was the way of the world, a single stage for the slow unfolding of life, a different configuration of the Earth's skin. It's a reminder that the world we see now, with its familiar continents and oceans, is just one frame in a very, very long film. The Earth is constantly rearranging its features, recycling its crust, breathing and shifting. Pangea was one particular breath, one particular arrangement in this endless, patient process. So, as you settle deeper into stillness, let the idea of Pangea wash over you like a gentle tide from that ancient, all-encompassing ocean, Panthalassa. Feel the quiet solidity of a world gathered together, a time before the Great Scattering. It's a story told not in words, but in the silent language of rocks, in the slow drift of continents, in the deep, patient rhythms of the Earth itself. It's a dream the Earth remembers, a time when all its lands were held close, sleeping together under an ancient sun, before the slow, inevitable stirring began and the next chapter of the planet's quiet, unceasing transformation started to unfold. The memory lingers, a whisper of unity from the deep past, carried on the slow currents of geological time. That stirring, however gentle, however slow, could not happen without leaving some trace, some faint signature upon the world. Like the quiet settling of dust after a deep breath, the Earth's movements, even those spanning epochs, leave behind subtle clues. These are not loud pronouncements, but quiet murmurs, whispers carried on the wind of ages, waiting for patient ears. Long after the great landmass of Pangea began its slow, inexorable fragmentation, long after the continents drifted towards the shapes we know today, the memory of their closeness remained etched into the planet's face and held within its rocky heart. These weren't memories easily accessed. They were like fragments of a dream half recalled upon waking, needing stillness and careful attention to piece together. Imagine, for a moment, tracing the edges of the world as we see it on a map. Follow the familiar curves and jags of the lands we call home. For centuries, keen eyes looked upon these shapes. Cartographers, sailors, naturalists, people simply curious about the form of the world, they saw the outlines. And some began to notice something curious, something almost too perfect to be chance. Look, they might have thought, tracing a finger across the globe, look at the great bulge of East and South America. Now, let your eye drift across the vast expanse of the Atlantic Ocean, that wide blue silence. See the deep indentation of Africa's western coast, the curve of the Gulf of Guinea. Don't they seem related, like two edges of a torn piece of parchment, holding the ghost of a connection? It's a gentle curve, a mirroring of forms. If you could somehow, with infinite patience and strength, nudge the vast continent of Africa westward, sliding it across the ocean floor, wouldn't it nestle snugly against South America? The fit isn't perfect, of course. Coastlines are constantly nibbled by waves, reshaped by rivers, built up or worn down over millennia. But the underlying shape, the deep structure suggested by the continental shelf hidden beneath the shallow waters, holds an uncanny resemblance. It's like finding two large, weathered stones on a beach, separated by yards of sand, yet bearing contours that whisper they were once a single boulder, broken apart by time and tide. This visual echo, this geographic rhyme, was one of the first whispers from the deep past. A suggestion, hanging in the air, that perhaps these immense landmasses, now separated by thousands of miles of salt water, were once neighbors, held in a close embrace. It was a startling idea, easy to dismiss as coincidence, a trick of the eye on a planetary scale. Yet, the whisper persisted, a quiet question mark drawn onto the map of the world. But the Earth holds its secrets not just in its grand shapes, but also deep within its substance, in the layers of rock laid down like the pages of an immense, silent book. And within these pages, preserved with incredible delicacy, are the forms of life that existed long ago. Not the creatures themselves, but their impressions, their mineralized remains, their quiet testimonies captured in stone. We call them fossils, these echoes of ancient beings, these sleepy remnants of a world unimaginably different from our own. And as scientists began to carefully excavate and study these stony sleepers, another layer of whispers emerged, adding a new voice to the story. They found, locked in the rocks of East and South America, the delicate fossil bones of a small reptile, a creature perhaps a yard long, with slender limbs and a long tail, adapted for life in fresh water. It swam in ancient lakes and rivers, a quiet presence in a long-vanished ecosystem. They named it Mesosaurus. It was a creature of the landlocked waters, not the vast, salty ocean. Imagine its small form paddling through calm, inland pools. Now, travel across the entire width of the South Atlantic Ocean, to the western coast of southern Africa. There, in rocks of the very same age, scientists found them again, the unmistakable, identical fossil remains of Mesosaurus. Think about this for a moment. This small, freshwater reptile, resting in stone on two continents now separated by an immense, formidable ocean barrier. How could this be? Could these little creatures have undertaken an impossible journey, swimming thousands of miles across a vast, salty sea, entirely unsuited to their nature? It seemed utterly implausible. Could identical creatures have somehow evolved independently, in precisely the same way, on two separate continents at the same time? That too seemed to strain belief beyond breaking point. The presence of sleepy Mesosaurus on both sides of the Atlantic was a profound riddle. Unless those two continents, South America and Africa were not separated by an ocean back when Mesosaurus paddled in its freshwater home. Unless they were joined, part of the same land, allowing these small reptiles to roam freely across lakes and rivers that spanned the connection. The fossils whispered a confirmation of what the coastlines only hinted at. The lands were joined. The fit was real. And Mesosaurus was not alone in its testimony. Other voices joined the chorus, whispering from the stone, "Consider the leaves of an ancient plant, a seed fern known as Glossopteris. Its distinctive tongue-shaped leaves are found fossilized in rocks of a similar age, not just in South America and Africa, but scattered across lands that are now incredibly distant and climatically diverse. These delicate leaf impressions appear in India, in Australia, and even in the frozen, ice-bound continent of Antarctica. Picture these ancient forests, these Glossopteris groves, spreading under an ancient sun. How could the seeds of this plant, likely heavy and not adapted for traveling vast distances by wind or water, possibly have crossed the immense oceans that now separate these continents? How could a plant needing certain conditions flourish in lands now ranging from tropical to polar? The distribution of Glossopteris fossils makes little sense in the world as we know it today. But imagine once again that these lands were clustered together. Imagine Pangea. Suddenly, the pattern becomes clear. Glossopteris wasn't undertaking impossible journeys across oceans. It was simply spreading across a connected landscape, a vast supercontinent where India, Australia, Antarctica, Africa, and South America were all neighbors. The sleepy leaves, preserved in rock across half the globe, whispered of this ancient unity, of a time when these now scattered lands formed a single, continuous realm for life to inhabit. Then there were the land-dwelling animals, creatures with no plausible way to cross deep oceans. Fossils of Lystrosaurus, a sturdy reptile sometimes described as looking a bit like a pig with a beak, have been found in Africa, India, and Antarctica. It was not a swimmer built for oceanic voyages. Its presence in these now far-flung locations speaks volumes, adding another layer to the quiet narrative. Similarly, fossils of Synognathus, a predatory reptile from the Triassic period, have been unearthed in both South America and Africa. Each discovery, each identical fossil, found sleeping in the rock on continents, separated by vast stretches of water, added weight to the growing suspicion. These weren't isolated coincidences. It was a pattern, consistent and compelling. The shapes of the continents seemed to fit, like pieces of a giant, broken jigsaw puzzle. And the pictures on those pieces, the fossils of ancient life, matched perfectly across the breaks. The sleepy creatures held in stone, the delicate ferns turned to rock, they all told the same story. They spoke of a time when the lands were joined, when Africa nestled against South America, when Antarctica and Australia and India were all part of the same great southern landmass, itself connected to the north. They whispered of Pangea, not as a myth or a guess, but as a reality reflected in the very fabric of the planet. This understanding didn't arrive in a sudden flash, but dawned slowly, like a long, quiet sunrise over the landscape of scientific thought. The whispers from the past, the matching coastlines and the congruent fossil beds began to suggest something truly profound. The continents themselves were not fixed in place. They had moved. They were moving still, just incredibly, imperceptibly slowly. This was the beginning of the idea of continental drift, the precursor to our modern understanding of plate tectonics. It was the recognition that the Earth's surface is not static, but engaged in a slow, majestic dance, a choreography spanning hundreds of millions of years. Imagine the continents as immense, slow-moving rafts, drifting on a deeper, unseen current within the Earth. Their journey is not measured in miles per hour, but in inches per year, a pace so slow it's almost impossible to perceive in a human lifetime. Yet, over the vast expanse of geological time, these tiny movements accumulate. Inches become miles, miles become thousands of miles. Continents that were once joined can drift apart, creating vast oceans between them. Others can slowly converge, pushing up mountains where they meet. This is the slow dance of the continents, a patient rearrangement of the world's geography. The matching coastlines are the memory of a time when the partners in this dance were held close. The fossils are the shared stories, the common heritage of lands that once moved as one. Finding Mesosaurus on both sides of the Atlantic is like finding matching lockets worn by two dancers who have long since drifted to opposite sides of the ballroom. Finding Glossopteris across 5 continents is like discovering the same forgotten melody woven into the histories of widely separated lands. These whispers from the past, carried in rock and shoreline, required a shift in perspective, a willingness to accept that the ground beneath our feet, seemingly so solid and permanent, is actually in constant, albeit incredibly slow, motion. It asked us to imagine time on a scale far grander than human history, and to see the Earth not as a finished sculpture, but as a work perpetually in progress. The clues were there, sleeping quietly, waiting for us to notice the fit of the coastlines, to listen to the stories told by the ancient, sleepy creatures held in stone, and to begin, finally, to understand the slow, deep, and unending dance of the continents that continues to shape our world, breath by quiet breath. The Earth holds its memories close, and sometimes, if we listen carefully enough, we can hear the echoes of its ancient choreography. And so, this slow, deep, and unending dance continues, breath by quiet breath, shaping our world even as we sleep. The choreography unfolds over timescales so vast they dwarf not just our lives, but the entire span of human memory and history. Imagine the Earth breathing, each inhale and exhale lasting millions of years. The movements are so gradual, so patient, that if you were to sit very still and watch a mountain range for your entire life, you would perceive no change. Yet, beneath that seeming stillness, the grand performance carries on, driven by the planet's deep internal warmth, a slow, simmering energy that keeps the continental rafts adrift on their long, meandering journeys across the globe. It happens while stars wheel overhead through countless nights, while forests grow and retreat, while ice ages come and go like slow tides. Our familiar world, the shapes of the lands we call home, the mountains we gaze upon, are but moments captured in this slow, unfolding dream of the Earth. Think of those continents that once nestled close, like Africa and South America, held together in the ancient embrace of Pangea. The beginning of their separation wasn't a sudden crack, but a slow, reluctant stretching. Deep beneath the surface, the land began to thin, pulled gently apart by the currents in the Earth's deeper layers, like warm honey slowly yielding. Imagine the crust sighing, stretching over millions of years, becoming brittle in places. Eventually, small cracks appeared, lengthening, deepening, until finally, a rift opened up, a long, thin wound upon the face of the supercontinent. Water, perhaps initially fresh from vast inland lakes or rivers, would have begun to seep into this nascent valley. Then, as the gap widened further, inch by painstaking inch over millennia, the salty waters of the surrounding ocean would have whispered their way in, slowly, tentatively at first, then flowing more confidently, claiming the newly forming space. This wasn't a flood, but a gradual inundation over ages, the birth of a new ocean basin, the Atlantic, growing wider with each passing century, pushing the two continents further and further apart. The coastlines we see today, those familiar curves on our maps, still hold the memory of that slow tearing, the echo of the original fit, like the slightly jagged edges of a carefully torn piece of paper, forever marking the place where they were once joined in that ancient, slumbering landmass. The Mid-Atlantic Ridge, that great underwater mountain range, remains like the seam of this slow separation, a place where new ocean floor is still quietly being born, widening the ocean basin even now, while we go about our days entirely unaware of the deep, slow pulse beneath the waves. But the dance isn't only about moving apart, it's also about coming together. When these immense, slow-drifting landmasses find their paths converging, the results are equally profound, though born of unimaginable pressure rather than gentle stretching. Imagine two titans meeting in the slowest collision imaginable, creeping towards each other over millions of years. This is how the great mountain ranges of our world are often born. Consider the towering Himalayas, the roof of the world. They stand as testament to the slow but inexorable journey of the landmass that is now India, drifting northwards after breaking away from the southern supercontinent, Gondwana. For tens of millions of years it traveled across a shrinking ocean, until finally it met the vast, immovable bulk of Asia. There was no sudden crash, no cataclysmic impact in human terms. Instead, it was a gradual meeting, like two enormous barges slowly nudging together, but the forces involved were immense, beyond comprehension. The crust beneath the ancient ocean separating them buckled and folded, pushed downwards, while the leading edge of the Indian plate began to crumple against the edge of Asia. With nowhere else to go, the land began to rise. Slowly, relentlessly, the rock layers folded like a giant rug being pushed from both ends. They fractured, buckled, and were thrust upwards, layer upon ancient layer. What was once seabed, holding the fossils of marine creatures, was lifted higher and higher, eventually reaching miles into the sky. This wasn't an overnight event, or even one that happened over centuries. It was a process spanning geological ages, mountains growing perhaps only fractions of an inch each year, lifted by the patient, irresistible pressure from below. While early humans walked the earth, while civilizations rose and fell in other parts of the world, the Himalayas were quietly, steadily growing, wrinkling the face of the planet, pushing skyward, sculpted not just by the collision, but also by the slow, patient work of wind, water, and ice, carving peaks and valleys into the uplifted rock. They stand there today, immense and silent, a monument to the incredible power of slow, persistent movement, a visible reminder that the ground beneath us is capable of reaching for the heavens, given enough time and pressure. Other ranges, like the Alps in Europe, tell similar stories of continents colliding, of landmasses squeezed and uplifted in this slow, ponderous ballet. Sometimes, the meeting isn't between two continents, but between a continent and the denser floor of an ocean. When this happens, the heavier oceanic plate doesn't crumple upwards in the same way. Instead, it performs a slow, deep bow, bending downwards and sliding gently beneath the edge of the lighter continental plate. This process is called subduction, a quiet yielding that happens deep beneath the waves. As the oceanic plate descends, it creates a deep trench in the ocean floor, marking the line where it begins its journey back into the Earth's warmer depths. Imagine the Mariana Trench, the deepest place on Earth, as the visible expression of this profound, slow bending of the oceanic crust. But the journey doesn't end there. As the descending plate sinks deeper, it carries water trapped within its rocks down into the hotter layers below. This water lowers the melting point of the surrounding mantle rock, causing it to melt and form magma. This molten rock, less dense than its surroundings, begins a slow journey back towards the surface. It rises like quiet, warm breaths through the overlying continental crust, pooling in chambers miles below. Eventually, some of this magma finds its way to the surface, erupting to build volcanoes. This is how chains of mountains like the Andes in South America were formed, standing tall along the edge of the continent, overlooking the deep trench offshore. Each volcano is like a chimney, venting the heat and material generated by the slow dive of the oceanic plate far below. These aren't necessarily explosive mountains all the time. Many grow layer by layer through quieter flows and eruptions over vast periods, standing like silent sentinels watching the ocean, born from the slow recycling of the Earth's crust. Similarly, when two oceanic plates meet, one will subduct beneath the other, leading to the formation of volcanic island arcs, chains of islands like Japan or the Aleutians, emerging slowly from the sea, built by the same process of melting and rising magma, forming stepping stones across the vast blue expanse. And then there are the places where the plates don't collide head-on or pull directly apart, but instead slide slowly past each other, like two enormous pieces of sandpaper rubbing edge to edge. These are the transform faults, the most famous perhaps being the San Andreas Fault in California. Here, the movement is horizontal. For long periods, the edges might stick, locked together by friction, while the deeper parts of the plates continue their relentless, slow creep. Stress builds up along the locked section, year after year, decade after decade, like winding a giant spring. Eventually, the stress overcomes the friction, and the rocks suddenly slip, releasing the stored energy in an earthquake. While the earthquakes themselves can be sudden and dramatic events on a human timescale, they are merely brief moments of release in the context of the fault's long, slow journey. Over millions of years, this sideways sliding shapes the landscape in more subtle ways too. Rivers can be offset, their courses abruptly jogging sideways where they cross the fault line. Valleys can form along the fault trace, marking the zone of crushed and weakened rock. It's a different kind of shaping, less about building towering mountains or vast oceans, and more about a slow, grinding shear that rearranges the features on the surface, leaving long, linear scars as evidence of the plate's sideways shuffle. So, as we rest, as we dream, the world continues its slow transformation. The continents drift, oceans widen or shrink, mountains rise grain by grain, and coastlines subtly shift. The familiar shapes on our maps are not fixed entities, but snapshots of a moment in geological time, the result of eons of this quiet, powerful movement. The mountains that seem so solid and permanent are still responding to the ancient pressures that lifted them, still being sculpted by erosion, while deep below, the plates continue their journey. The coastlines are not static boundaries, but places of constant, slow change, shaped by the rising and falling of sea levels, the deposition of sediment, and the underlying drift of the landmass itself. Our world is not a finished piece, but a dynamic, breathing entity, constantly reshaping itself according to the rules of this deep, slow dance. The ground beneath our feet holds the rhythm of this dance, a rhythm so slow we cannot feel it, yet so powerful it builds mountains and moves continents across the face of the earth, shaping our world while we dream, ensuring that the planet we awaken to tomorrow is, in infinitesimal ways, different from the one we knew today. The ancient choreography continues, its effects written large across the landscapes we inhabit, a silent, ongoing creation story told in rock and time, a constantly dreaming earth. And so, the world beneath our feet carries on its quiet work, even as we turn in our sleep. Think of the earth itself as dreaming, not in sudden bursts of thought, but in slow, unfolding ages of change. The dance we spoke of, the ancient choreography of the plates, is the rhythm of this planetary dream. It's a dream measured not in heartbeats, but in the steady creep of continents, the slow widening of oceans, the patient rise and fall of mountains over millions upon millions of years. It's a process so fundamental, so deeply ingrained in the planet's being, that it continues without pause, a constant, quiet hum beneath the noise of our fleeting days. Imagine sinking deep below the surface, deeper than the deepest mines, past the solid rock of the crust, into the realm of the mantle. Here, the rock behaves differently. Under immense pressure and unimaginable heat radiating from the planet's core, it flows. Not like water, but perhaps like honey left in the cold, or thick tar warming slowly in the sun, an incredibly slow, viscous circulation. These are the convection currents, the hidden engine driving the continents above. Picture vast, slow-motion rivers of heat rising from the deep interior, spreading out beneath the rigid plates, carrying them along like leaves on a barely moving stream. Where these currents rise and diverge, they gently nudge the plates apart. Where they cool and sink back down into the depths, they pull the overlying crust along with them, drawing it back into the planet's warm embrace. This circulation is not violent. It is immensely powerful, yes, but its power lies in its persistence, its sheer, unwavering slowness. It is the planet breathing in geological time, a slow inhale and exhale that spans epochs. The heat from the core, a relic of the Earth's fiery formation, and the slow decay of radioactive elements must escape. This mantle convection is the most patient, most profound way the Earth releases its inner warmth, and in doing so, it reshapes everything we see on the surface. It's a process that has continued for billions of years, a slow, rhythmic pulse deep within the Earth, ensuring that the surface above is never truly static, never finally settled. Think again of those places where new crust is born, the mid-ocean ridges. In the context of this dreaming Earth, they are not sites of fiery eruption, but places of quiet, steady creation. Imagine the mantle gently welling up, the pressure lessening as it rises, allowing the rock to melt and form magma. This magma doesn't burst forth, rather, it seeps, it oozes, filling the narrow gap created as two plates drift slowly apart. It cools and solidifies, adding infinitesimally thin strips of new ocean floor to the trailing edges of the plates. It's like the Earth is slowly knitting new fabric at these seams, widening the oceans centimeter by centimeter, year after year. The Atlantic Ocean, for instance, grows wider by about the speed your fingernails grow. It's a creation happening constantly, silently, in the dark, cold depths, a testament to the planet's ongoing, quiet renewal. This is the Earth stretching in its sleep, making a little more room. And where the plates move towards each other, where the old ocean floor meets the edge of a continent or another oceanic plate, there is a different kind of quiet process unfolding. One plate, usually the older, colder, denser one, bends and slides beneath the other, sinking back into the mantle from whence it came. This is subduction. Seen not as a collision, but as part of the Earth's slow dream, it becomes a graceful return, a recycling. The plate doesn't shatter. It yields, folding downwards, carrying its burden of ocean sediment and water deep into the Earth. As it descends, it warms, releasing water that lowers the melting point of the overlying mantle wedge, causing magma to form. This magma, buoyant and hot, rises slowly towards the surface. Sometimes it pools beneath the crust, cooling slowly to form vast bodies of granite. Sometimes it finds pathways to the surface, feeding volcanoes. Even these volcanoes, which seem so dramatic to us, can be viewed as part of the slow dream. They are like vents, allowing the Earth to exhale some of the heat and material generated by the slow recycling process deep below. While an eruption is a sudden event on our timescale, the processes leading to it, the slow descent of the plate, the gradual melting, the patient rise of magma, take millions of years. The volcanoes themselves are often built layer by slow layer, eruption by quiet eruption, over vast stretches of time, becoming sleeping giants that punctuate the landscape, markers of the deep, slow processes occurring beneath. They are sighs in the Earth's long slumber. Where continents collide, the dream takes a different form. Because continental crust is thick and buoyant, it resists being forced down into the mantle. So, when two continents, carried along by their respective plates, meet, they crumple. Imagine two thick rugs being pushed slowly together across a floor. They wrinkle, they fold, they pile up. This is how the great mountain ranges like the Himalayas or the Alps are born. It is not a sudden crash, but an inexorably slow compression. The pressure builds gradually over millions of years, causing the rock layers to bend, fold, and fracture. The crust thickens, pushing downwards into the mantle like the root of a vast tree, and simultaneously rising upwards towards the sky. This mountain building is perhaps one of the most visible manifestations of the Earth's slow dream. We see the towering peaks, the folded rock layers exposed on cliff faces, the sheer scale of the uplift. Yet, even here, the process is dominated by slowness. The mountains rise millimeter by millimeter, year after year. While earthquakes might punctuate the process, marking sudden adjustments to the immense stress, the overall growth is gradual, patient. It's as if the Earth, in its dreaming, is slowly furrowing its brow, creating these majestic wrinkles on its surface. These mountains, which seem so permanent, so ancient and unchanging to us, are still actively responding to these deep-seated pressures, still growing, still being shaped by the slow, continental embrace. And even the sideways sliding of plates, the transform faults like the San Andreas, fits within this dreamlike state. The long periods of quiet, where the plates are locked, are like moments of stillness in sleep. The stress builds almost imperceptibly, a slow tightening deep within the rock. The earthquakes, when they happen, are like sudden twitches, brief releases of tension before the slow, steady movement resumes. Over the vast expanse of geological time, this sideways shuffle patiently rearranges the landscape, offsetting rivers, carving long valleys, grinding rock against rock in a slow, persistent shear. It's less about building or destroying, and more about a quiet, continuous rearrangement, like shifting positions slightly in a long, deep sleep. While the deep Earth dreams of movement and creation, the surface world responds with its own quiet patience. The forces of erosion, wind, water, ice, begin their work almost as soon as land is lifted. Rain falls softly, yet over millennia, it dissolves the hardest stone, molecule by molecule. Rivers, born in the high mountains, carve their paths downwards, carrying tiny grains of sand and silt, the remnants of ancient peaks, towards the sea. Glaciers, like immense slow-moving rivers of ice, grind and scour the landscape, deepening valleys and polishing bedrock. The wind picks up fine particles, sandblasting rock faces and transporting dust across continents. This erosion is the gentle counterpoint to the constructive forces of tectonics. It is the Earth smoothing its own features, softening the sharp edges, slowly returning the uplifted land back towards sea level. It's a process just as relentless, just as continuous as the plate movements themselves, but working in the opposite direction. The sediment produced by this slow wearing down travels downstream, eventually settling in low-lying areas, in lakes, and most importantly, in the vast ocean basins. Layer upon layer, this sediment accumulates, burying older layers beneath. These layers become rock themselves, sandstone, shale, limestone, trapping within them fossils and clues about past environments. They form a blanket of memory, preserving the history of the Earth's surface, even as the deeper dream continues. This cycle of uplift, erosion, and deposition is part of the planet's slow breathing, constantly reshaping the interface between rock, water, and air. The sheer timescale of these processes is difficult to truly comprehend. We live our lives in days, seasons, years. The Earth dreams in millions and billions of years. The movement of a continent by a few centimeters in a year seems utterly insignificant, yet over 100 million years, that amounts to thousands of kilometers. Enough to open an entire ocean, or to bring continents together from opposite sides of the globe. It's this immensity of time that allows such slow, gentle movements to achieve such dramatic results. The mountains seem static because our lifespan is a mere blink compared to the time it takes for them to rise or erode. The continents feel fixed beneath our feet because we cannot perceive their leisurely drift across the globe. And so, the Earth continues its constant, quiet transformation. It is not a static ball of rock, but a dynamic system, constantly recycling its crust, rearranging its features, adjusting its balance. This ongoing process is, for the most part, profoundly peaceful. The energy released in earthquakes and volcanoes is tiny compared to the vast, slow energy involved in mantle convection and plate movement. The dominant mode of change is this slow, steady creep, this gradual reshaping. The planet is not in turmoil. It is simply alive in its own geological way, breathing slowly, shifting gently, constantly becoming something slightly new. As we settle into stillness, letting the day's concerns drift away, we can perhaps feel a connection to this deeper, slower rhythm. The ground beneath us is not just solid, inert matter. It is the surface of a world engaged in an endless, slow-motion dream. Continents are wandering, oceans are breathing, mountains are slowly rising and falling back into the earth. The planet is turning in its sleep, reshaping itself grain by grain, centimeter by centimeter. The world we wake to tomorrow will be infinitesimally different from the one we leave tonight, changed by the quiet, relentless, peaceful processes of a constantly dreaming Earth. It is a slow, unfolding creation, a story written in rock and time, continuing forever beneath our feet, ensuring that our world is always, subtly, wonderfully, renewing itself. So now, as the world outside grows quiet and the stars begin their slow turn across the sky, think about those giant puzzle pieces, the tectonic plates, continuing their silent journey. They drift, oh so slowly, across the Earth's surface, carrying continents and oceans with them like patient rafts on an unseen current. It's a dance that has been going on for billions of years, a rhythm measured not in heartbeats or breaths, but in the slow stretching of ages, the gradual unfolding of geological time. The mountains we talked about, pushed up high, like wrinkles in a giant soft blanket, didn't appear overnight in a sudden burst of creation. They grew millimeter by millimeter, year after year, century after century, pushed upwards by the steady, almost unimaginable pressure where two plates decided to meet and embrace, or perhaps, to argue gently and crumple upwards towards the sky. It's a process so slow, so patient, that compared to it, even the oldest, wisest trees seem fleeting visitors, and the longest human life is just a momentary blink in the deep, slow gaze of Earth time. Imagine the ground beneath your bed, beneath the house, stretching down, down, down through layers of soil and rock. It feels solid, doesn't it? Stable and reassuringly still. Yet, deep below, within the Earth's warm mantle, the rock is not entirely still. It flows like incredibly thick, warm honey over vast timescales, a slow, convective river carrying the land you live on. The floor beneath you, the foundation of your home, is part of one of those enormous plates. Perhaps the North American plate, or the Eurasian plate, or another giant raft of rock floating on that deeper softness. It's moving right now, perhaps at the same quiet speed that your fingernails grow, drifting towards or away from another plate, somewhere far across the globe, beneath distant lands or wide oceans. The oceans too rest upon these moving foundations. The Atlantic Ocean, for instance, is slowly growing wider, breathing outwards as the plates beneath it drift apart like partners stepping back in a slow dance, allowing new ocean floor to well up softly from the depths, like a slow, silent spring of dark rock solidifying in the cold water. The Pacific, in other places, is gently shrinking as its edges slide smoothly beneath continents and island arcs. In that process, we called subduction, returning the old, cold ocean floor back into the Earth's warm embrace to be recycled, melted down, and perhaps one day reborn. This constant, quiet movement is what makes our Earth such a dynamic and vibrant place. It's not a static ball of rock hanging in space. It's alive with energy deep within its core and mantle. Think of it like the planet breathing, a very slow, deep breath that takes millions upon millions of years to fully inhale and exhale. This profound planetary breath shapes everything we see and experience on the surface. It builds the majestic mountains that scrape the sky, providing slopes for snow and sources for rivers. It carves the deep valleys where those rivers flow towards the sea, shaping landscapes over millennia. It forms the vast, low basins that hold the ocean's blue waters, home to so much life. Even the air we breathe is subtly connected to these deep earth processes, as volcanoes, often born from the meeting and melting of plates at their edges, release gases and water vapor that become part of our atmosphere, influencing climate and weather over long stretches of time. It's all connected, a beautiful, intricate system where the deep, hidden movements below orchestrate the grand, visible landscapes above and even touch the sky. As you drift towards sleep, let your imagination paint a picture of those continents continuing their slow waltz across the globe. Africa continuing its gentle nudge against Europe, pushing up the Alps just a tiny fraction higher each year, a growth too small to see but relentless over ages. India, having already crumpled the edge of Asia to form the towering Himalayas, continues its steady press northward, a persistent geological hug. Australia drifts slowly, patiently, towards Asia, perhaps dreaming of joining the mainland in some distant future epoch, millions of years from now. What will the Earth look like then? It's a fascinating thought, a glimpse into a future shaped by forces we are only just beginning to fully understand. Perhaps the continents will gather together again, drawn by the slow currents below, forming a new supercontinent like Pangea was long ago, surrounded by a single, vast global ocean. Or maybe they will continue to drift and rearrange themselves into entirely new patterns, creating geographies we can only guess at. New mountain ranges will undoubtedly rise, folded and lifted by future collisions. Old ones will gradually wear down under the patient, persistent work of wind, water, and ice. And new oceans might open up where today there is dry land, changing the map of the world in ways profound and slow. The Earth will continue its slow, geological dream, reshaping itself long after our own dreams have faded with the morning light. But for now, here in the quiet dark of your room, everything feels peaceful and secure. The immense power we talked about, the grinding plates, the molten rock deep below, the colossal forces that lift mountains towards the clouds, seems very far away, part of a story rather than immediate reality. And in a way, it is. It operates on a scale of time and space that is difficult for our minds, accustomed to days and years, to truly grasp. Yet, it is also right here, beneath your feet, part of the very ground that supports you, the foundation of your world. It's a quiet reminder that even in stillness, there is profound movement. Even in silence, there is a deep, underlying rhythm to the planet. The gentle rocking of a cradle is nothing compared to the slow drift of a continent carrying you across the face of the earth, yet both are forms of movement, one soothing you towards sleep, the other shaping the world you will wake up in tomorrow morning. Feel the stillness around you, the safety and comfort of your bed, your room. It's a small pocket of calm resting gently on the surface of a slowly, constantly changing planet. These movements, these earthquakes and volcanoes that sometimes punctuate the slow geological narrative, can sometimes seem scary when we hear about them. They remind us of the Earth's incredible power, a power far greater than our own, but they are also entirely natural processes, part of the planet's way of being, its method of adjusting and releasing energy. They are not angry or chaotic events in themselves, but rather the predictable results of these slow, steady plate movements releasing built-up stress along faults, or allowing deep heat and molten rock to escape to the surface. They are the planet adjusting itself, like someone shifting in their sleep to find a more comfortable position. And these very processes, this tectonic activity, are essential for maintaining a living planet over the long term. The recycling of rock through subduction and volcanic activity helps regulate our planet's climate over geological timescales, keeping it habitable. The minerals brought up from deep within the Earth by volcanic activity enrich the soil, allowing plants to grow strong and supporting the food chains that depend on them. The changing shapes of continents and oceans influence ocean currents and atmospheric circulation, creating diverse climates and habitats for all kinds of creatures to evolve and thrive. So, in a very real way, the slow dance of the plates is also the fundamental rhythm that life on Earth moves to, the deep beat shaping the stage upon which life unfolds. So let your mind drift now, easily and calmly, perhaps like one of those continents on its slow, inexorable journey across the deep. Let the knowledge of this vast, slow process be a comforting thought, not a worrisome one, a sign of the enduring, resilient nature of our world. The Earth is taking care of itself in its own way, constantly renewing its surface, building and rebuilding in its own immense timescale. While you sleep tonight, the plates will continue their silent creep. The mountains will grow just that tiny, invisible fraction taller. The oceans will shift imperceptibly in their basins. It's a grand, slow-motion ballet happening all around you, beneath you, across the entire globe, a silent testament to the planet's inner life. There's no need to worry about it. It's been happening for longer than anything we can truly measure and will continue long after we wake. It's just the way our wonderful, dynamic planet works. Close your eyes now and feel the quiet stability of your bed, a tiny island of peace adrift on the surface of our ever-changing, ever-evolving Earth. Rest easy, knowing that even the solid ground beneath you dreams its own slow, geological dreams, shaping the future landscape. Sleep well. And perhaps you too will dream of drifting continents and rising mountains, all part of the gentle, endless, unfolding story of our planet Earth. The story continues, always continues, written slowly and surely in rock and time. Good night.